sometimes it just really helps to draw a picture. So I'm given a triangle. The triangle is called ABC, and I'm told that two of the sides of the triangle are congruent to each other, and I'm given the measure of one and only one of the angles. That seems like using the triangle angle sum theorem might make it difficult to find the other two. But let's sketch this. So I'm going to sketch a triangle. I don't know, just some kind of a generic triangle. That's a nice, that almost looks like it's isosceles. But in this triangle, they tell me that, well, I guess I'll label this A, and I'll call this B, and I'll call this C. I'm told that segment AC is congruent to segment AB. So this segment is congruent to this segment. And I'm asked, well, and I'm also told that the measure of angle A is 50 degrees. The question is, what is the measurement of angle B? I'm asked to find that. Well, I do know that if I'm labeling that one X, if I take 50 degrees and I add to that the measure of angle X, and I add to that the measure of the angle at vertex C, right, I get 180 degrees. My problem is I don't know enough about these two angles. Well, this triangle is special. It's because I'm told that two of the sides are congruent. This is called an isosceles triangle. And it turns out if we have an isosceles triangle, there's a theorem that applies to it. So I want to tell you that theorem, and then I want to briefly convince you that it's true. So an isosceles triangle is a triangle in which at least two of the sides are congruent. So just visually, it appears that these two sides are congruent. So I'm going to mark these sides congruent. And the isosceles triangle theorem states that if you have an isosceles triangle, then the angles across from the congruent sides are congruent. So what this is saying is that if this is isosceles, this angle here, right, which is across from this side, has to be congruent to this angle. These angles must be congruent according to this theorem. Now the proof of this theorem is fairly straightforward, and we're just going to talk through it quickly. And it has to do with congruent triangles. So after this proof, after we understand this proof, right, we can just use this proof. We don't have to keep writing this. So when we see an isosceles triangle, we can say, hey, because of the isosceles triangle theorem, those opposite angles are congruent. Here's what the proof looks like. I'm going to draw something called an auxiliary line. This is a line that I'm adding to this diagram, and I'm only claiming one thing about this line because I can't claim multiple things because I don't know that they're true. The thing that I'm claiming is that this line that I just drew is an angle bisector, right? And I got to be careful. I don't know that these sides down here are congruent. So I'm claiming this is an angle bisector, and that means that it's going to create two congruent angles. These angles are congruent to each other because I'm bisecting this angle, and I'll label this angle A, and this I'll label B, and this I'll label C. So I bisected angle A. Whenever I bisect an angle, I create two new congruent angles. So angle, let me give this a name down here. By the way, I'm not claiming it's a right triangle either. I'll call this D. So my claim is that I bisected angle A. That means that angle BAD is congruent to angle CAD. I just said these two angles right here. The other thing that's true is that AD is congruent to itself by the reflexive property. So I'll mark that on this diagram. So if we look at what we have, right, we have that these two triangles, triangle BAD, I'll write that down. We have triangle BAD is congruent to triangle CAD, CAD, and those are congruent to each other by side, angle, side. You see I clearly have the sides, this side, the included angle, and then this shared side down the middle. So they're congruent because I can write a proof, and I just verbally wrote the proof with my words, that those triangles have to be congruent to each other. Now, because those triangles are congruent, right, because I established the fact that they are congruent, it has to be that all their corresponding parts are congruent. Remember, the definition of a congruent triangle goes both ways. If you show 6 things are true, then you have congruent triangles. But if you show that the triangles are congruent, in this case I did it with just 3 things, all the corresponding points then must be congruent. So angle B and angle C must be the same. Angle B must be congruent to angle C. And the reason why is they are both corresponding parts of the triangles that we just demonstrated were congruent. So now that we understand the proof of the isosceles triangle theorem, and we understand that we have from this diagram an isosceles triangle, we can say, well, this is nice. Both angle B and angle C are the same. So I can say, take my 50 degrees, and then I'm going to add to that x, and I can add that to that another x, and I'm going to get 180. Therefore, 2x must be equal to 130, and x is going to have to equal 130 divided by 2. So there you go. We know the measurement of angle B, even though it felt like we just knew 2 of the angles.